Hello, this is part H of question 1 on Math 2017. So here we're told that a and b are real numbers and that a is not equal to 0, and that when this quadratic is divided by x plus b, we get remainder 1, and also that this quadratic has ax minus 1 as a factor, and we want to know what b must equal. Okay, so we're dividing by polynomials and talking about remainders and stuff, so let's use the remainder theorem. So this basically says that when we have a polynomial f of x, and we divide by a linear polynomial like this, then our remainder is basically going to be the same as putting the root of this into our f of x. So using that on our first bit of information here, we're dividing this quadratic by x plus b. The root of this is minus b, so the remainder is just going to be the same as putting minus b into our quadratic, which is the left hand side here, and we're told that that's equal to 1. And now for the second bit of information, the root of this is 1 over a. So because this is a factor of this, when we put 1 over a into here, we're going to get 0. So now we've basically got two simultaneous equations for a and b, and you can either solve these equations for b or use the values that they give you, substitute them in and see which one gives you a consistent answer for a. So first, if we were just to solve these equations, let me label my equations 1 and 2. Then if we simplify them, we have these here, and multiplying through this equation by a squared to get rid of the fraction, we have this, and now that can be rearranged to find b. So now if we put this value of b into 1, this is what we get if we just substitute straight in. And, oh sorry, I'm missing a squared here I think. So now let's simplify that. We eventually get down to 2a to the 4 minus a squared equals 1. So noticing that these a cubes cancel and having the a squared minus 2a squared. So let me rewrite this. So what we have now is basically a quadratic in a squared. And if I rewrite this minus a squared as minus 2a squared plus a squared, then we can see that actually this factorizes exactly. And what we end up with is either a squared equal to minus half or a squared equals 1. And of course, we can't have a real a and having a squared equaling minus half. So a squared equals 1 is the root we're going to want to take. And that must mean that a is either 1 or minus 1. And remember, b is minus a squared, then substituting a equals 1 and minus 1 into this formula for b, we get that b is either minus 2 or 0, and that means that our answer is b. Now the other way I mentioned was just to use the answers that they give you. So we see that 1 appears in the most number of answers, so let's try b equals 1 first. Substituting b equals 1 into our equations 1 and 2, we end up with these, and you can see that this is actually a quadratic without any real roots. So if b were 1, then we wouldn't be able to find a real a which satisfies both these equations. So b can't be 1, and we get rid of a lot of these possible answers. And next we want to try either one of these two or one of these two. And if it works, then you know that's the answer. If it doesn't work, you know the other one's the answer. So you've already seen that if I put b is equal to 0 into these, then a equals minus 1 will solve both of them, and if I put minus 2, then a equals 1 will solve both of them. So I guess I might as well show you one of these. So say I put b equal minus 1. So putting b equal to minus 1 into both of 1 and 2, we get these. And solving the first one, we see that either a must be 0 or a must be cube root of 2. And solving the second one, we see that we would need a to be minus 1 plus or minus root 5 over 2. So if b were minus 1, we would not be able to find the a which satisfies both these equations. Therefore, b cannot be minus 1 for this to work, so you can rule out e, and then you know the answer is b.